Hi, it's Milasoft. In this video, we're going to learn a little bit about rasters and interrupts. We're going to get into the fun stuff. Now, you can see on the 64 screen, the cursor is flashing, and if we check the time clock, the time is changing. This all happens in the background, independent of what you're doing. And for that, we have to look at location 0314 and 0315. You'll notice that it points to EA31. If I go to EA31 and I assemble something like increment the border color and I exit, nothing happens because E1000 is part of the ROM. So I'd like you to think of it as an analogy. Let's say that once a week you have someone come to your house to do cleaning and you leave them a list to do the kitchen counter, to clean the floors, do the windows, and the list is pretty much the same every week. That is what location 0314 and 0315 are for. This is the low byte and this is the high. So it points to EA31, which is just that. It's a list of things for the computer to do. Flash the cursor, update the time clock, other necessary routines. And it does that 60 times a second. So you want to have some friends over to watch a game on TV, and you want to change the list for your housekeeper. You want to put in, I'd like you to vacuum the carpet in the rec room. So you want to modify the list. And that is what you do with the IRQ on the 64. If you want it to do more than just update the clock and flash the cursor and the normal background routines, then you have to change the list. Now we can't change EA31 because it's part of the ROM, but we can change 0314 and 0315. The important thing to remember is we always have to resume back to EA31. So I'm going to give you another analogy. This is the plumbing in your house. I think it's easier to learn with an analogy. Your hot water is right here. And this is the plumbing, and this is your tap. So if you want hot water, you open the faucet, and out comes hot water. And then the wife decides that she would like to have another tap installed somewhere, or maybe a shower, what have you. So you tap in to the plumbing. You tap into the water supply, and there's your new, whatever, shower, bath, what have you. So on the 64, the IRQ works pretty much the same way. What you're doing is you're saying, well, I want you to go to 0314, 0315, and instead of exiting out by EA31, instead of executing EA31, I want you to go down here and call my routine now. It's going to be flash the border. And as long as you tell it to go back to EA31 when you're finished, you're perfectly fine. You can divert it away as long as you send it back, because it still has to do this maintenance. Are you a little bit confused? I'm going to show you a really simple example. I'm going to go into the monitor. I'm going to assemble a routine at 033C. I'm going to SEI, which temporarily stops the interrupts. Because if you change it while it's in the middle of doing something, the results can be, not desirable. So wait for it to be a good time. And then we're going to load, let's say 50. Put it in 0314, which is the low byte of the IRQ. Load 03. Put it in the high byte. CLI means you can resume the interrupts. It releases the hold. And then RTS, so it can go back to basic. Stop interrupts, change it to point to 0350 instead of EA31, because we can change this. We can't change EA31, it's in the ROM, but we can change the pointer. We can divert it. So now it's going to go to 350, where we're going to increment the border color. And as long as we send it back on its merry way to EA31 when it's finished, we successfully, there we go, we successfully have diverted it. So if we look at 0314 now, we see it's not pointing to 31EA, but it's pointing to 0350, which increments the border, and then jumps EA31. So we've just diverted it. And that is where today's lesson comes in. We're going to make a raster bar. So I'm using C64 Studio, and we're going to begin by putting star equals 49152. You can also use C64 PRG Studio, Program Studio, or any type of a GUI environment that allows you to assemble in text on the Commodore. This is a Windows program, C64 Studio, and you have to start with star equals 49152, so it knows where to put the code. And then we're going to put SEI, just as I showed you, which will temporarily stop the interrupts. Let's just have a look here and see, what does SEI mean in 6502? Set interrupt disable status. So we're disabling it for a moment. Now this here, I don't really expect you to understand off the get-go, but we're disabling the CIA interrupts, and then we're clearing the pending. So we're putting 7F into DCOD and DDOD. 7F in binary is 0, 111, 1111, and essentially we're just disabling. This is something that even I don't quite fully understand. I've never been very good at understanding the VIC register. And here is where we set 0314 and 0315. You'll notice that I'm not putting numbers in here. I have number sign less than IRQ, and then number sign greater than. That is because I don't know where in memory IRQ is going to be. What if I want to put in something like NOP, NOP? That pushes down everything by 2 memory addresses. So I'd have to constantly be changing this from, say, 0350 to 0352. You know, I wouldn't know where the heck it is. So using the less than greater sign, it's saying take the low byte. Number sign less than is the low byte. Put it in 0314 and take the high byte. And that'll work for pretty much any command that you want to get the low and high byte for. If you want to, figure out what the low of the border is and the high byte. So I'm going to just go over it again. 49152 is the start address. We want to temporarily stop the interrupts. This, you don't necessarily have to understand it. It's just acknowledging the CIA timer. And then we're setting the low byte of the IRQ. We're putting it into A and throwing that in 0314. And then we're taking the high byte and putting it in 0315. And then we set 1B in D011 which is it's the raster register. The raster, let me just explain the raster to you quickly. It's essential for this. So on your 64 screen, picture a man on a scaffold painting. He's painting, he starts from here, and he looks at 53280, the border color, to figure out what color can of paint. And he paints from left to right like this, goes back to the next line like that, and then he gets here, and then he paints the screen, and then he does the border again, and he works his way all the way down to the bottom. If you want a new color, you just poke it into the proper register, and there you go. But this is not happening instantaneously. What's happening is, as he's painting, let's say he's here, and you change the border color to gray. He starts painting gray from here on down, and then when he gets back to the top, he paints gray again. It happens so quickly that you don't see it, but this is not instantaneous. It's happening on the exact line that this painter is painting the screen. Now, the proper term for it is raster line, and it's at location D012. So just keep that in mind. If you want to take control of the screen, if you want everything to stay static, like just have text here and text here, but you want to have this line here a smooth scroll, well, what you have to do is you have to wait for the painter or the raster line to come down to here, and then change the X position of the screen. So that would be 53270. You can go 199, 198. See how it's shifting? 197, 196, 195. Now you can only move 7 pixels, and then you have to stop. And then for the eighth position, you physically move the characters over. So what's happening is it's giving the illusion of shifting to the left. And then for that final 8th position, you physically move everything over 1. And then you continue shifting the screen pixel-wise. We'll get into that a little bit later, but that's how you do a smooth scroll. You wait for the raster line to get to a certain point, and then you change 53270. But then when you're done the area of the smooth scroll, you set 53270 back to what it should be. Otherwise, you have the whole screen moving to the left, and you don't want that. Or maybe you do. But that's how a smooth scroll works, is that in 53270, you keep it stable, keep it what it is, till it hits the point you want your smooth scroll, and then you change it. And because the painter guy is going down and painting the border in the screen, he's also setting 53270. So he keeps it like this, solid, nothing's moving, until he gets to the scroll, and then whatever that is, it shifts over just for that part of the screen. And that's the beauty of the raster, is it forgets everything it's done. So if you have, and I've covered this in a previous video, say you have 4 sprites on the screen, 8 sprites. All right, there's 8 sprites. And it's drawn them on the screen, and the raster line comes down. If you redefine new Y values, and new X values too if you want, for the sprites, it will redraw them. It doesn't know that it's already done 8 sprites. It's just handling the here and now, and you can have more than 8 sprites. So, back to our example. We've set 0314 and 0315 to a new routine called IRQ. We've set D011, which is, let's look it up and see what it has to say. A register, a variety of control bits. Vertical tweaks. Bit 7 is the most significant bit, 9-bit raster register. So bit 7, they work together. D011 and D012 work together to be what line this little painter guy is on, the raster register. D012 is going to be what we want to deal with. We set D01A to a 1 to enable raster IRQs. CLI to clear the interrupt that we halted. We said these work together, SEI and CLI. SEI temporarily stops, says we want to change something. CLI, okay, you can resume what you were doing. RTS, so it goes back to basic. You want it to say ready when you're done. And it takes over. And then what we're going to do is we're going to load one and store it in D019 to acknowledge that the raster interrupt has occurred. And we're going to reset. Don't think this is quite right. No, let's take this out. So what's going to happen is it's going to fire when the painter guy gets down to 52. D012 is the location of the painter. When he reaches 52, this IRQ is going to fire. So it's going to go here. It's going to acknowledge that it has happened. Okay. It's going to load X with 0 and load COL, which is a little table of colors, comma X. It's going to load D012, compare Y to D012, and if it's equal, go back up. And we're doing this because, so let's say that he's on his way down, this little raster, and he's here. Okay, so this is line 52, but he's like right here. He's not at the start where he should be. So we load Y with D012, and we compare it to itself. And if it's branch equal, go back up to the compare. So Y has a value right here of D012, which could be, let's say, 52. And we compare it to itself. And as long as it's equal, it means it's still on the same line, because we don't want it to draw a line when it's not at the start of the screen. So we compare it to itself until it's no longer equal, meaning that it has finished drawing and it's on a fresh line ready for us to draw. And it takes whatever color is here, which is 9, and stores it in the border and screen. So it paints it across the screen, the little painter guy, and it increments X, so it becomes 1. It goes from 0 to 1, and then compares X to 8. Is it 8? Yeah. Nope, it's 1, so go back up to loop. It loads color, comma X, so it now takes an 8. But he's still drawing the 9. He's not ready yet. And again, that's where this takes effect. Load Y with D012, compare it to itself. Is it equal? He's still on the same line. Then just go back up. And this is a label I'm using, the minus sign. We can put, we can call it looper. Minus sign is the same thing as, it's just a label to say go back up. So it's going to wait until he's finished drawing. And then when he's on the next line, the previous value of D012 is still in Y. When it compares to D012, it's going to be branch not equal. He's on a new line, and now it draws the next color. So this here ensures that the line, the raster line, is on a fresh position before it draws into D020, D021. And then increments X, so it's going to put 9, 8, 7, 1, 7, 8, 9. And the final value is 0 because we want it to be black. And I'm going to show you what it does when it works. SYS 49152, and we now have a solid raster bar. Look at that. It's not perfect. You can see it flickers when we type, but for all intents and purposes, we have a raster bar. Painter guy's coming down, and when it hits 52 in DO12, it says, okay, we want you to go to iRoutine, acknowledge that you've received a request, load X was 0, take the color 9, which is the little orange. He's painting it, painting it, painting it, painting it. By now, it's already moved. Actually, no, it's still waiting for him to finish the line. And then it goes back up to loop, grabs the next color. Yeah, and then it waits for him to finish it. I'm hoping that makes sense. Just picture a guy with a can of paint drawing the screen. So he's doing 0, black, 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 black. And then when it hits 52, we've loaded A with color, comma X, where X is 0, so it takes a 9. And then we take DO12, which is basically the Y position of his scaffold as he makes his way down, and compare it to itself, because we don't want him to start painting here or here or here. We want him to do it when they're mismatched. The current position is no longer equal to his new position, meaning he's ready to start on a brand new line. Start in DO20, DO21, so he dips into his can of paint, and he says, okay, I'm now painting with 9. And that's this very first strip of color. We increment X, so it goes to the 8, which is kind of like a light orange, and it's already back up here waiting for him to be on the fresh line. But we can do more. We can do much more than that. Why don't we do a rolling raster bar? So we're going to load X with 0. The source code for this will be in the video description too. So we're going to load X with 0. We're going to load A with color, comma X. So this is color. X is 0, so this is the first position, 0. And we're going to push it to the stack. In another video, I described the stack as basically you're helping a friend stack cases of beer or pop in his house, and you stack them on top of one another. So the last value that you push on is the first value you take off. You're not going to grab a case of pop from the bottom. So we're taking the 9 and we're just pushing it to the stack. We're putting it in a temporary holding position. And then we're going to load color +1, comma X. And the assembler is going to say, oh, okay, I know where call is. It's right here. It's CO4F. You want to take it +1, so it's going to take CO50, this value right here, the 8. The assembler knows when you put +1, -1, plus a label, it knows, okay, he wants this one here. So I'm going to load the 8, and we're going to store it in color, comma X. So what I've done is I've said, okay, X is 0. Take the 9, push it to the stack. So 9 is, I'm just going to temporarily write it here in the stack. Color +1, which is 8. Store it in COL, comma X, where X is 0. So it's going to take the 8 and move him over here, where the 9 is. Because it's column, or color +1, storing it in color. It's the +1 that moves it ahead 1. And then we're going to increment X and compare X to, I think it's 8. 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, I guess it's 7. And if it's branch not equal, let's just put K. That'll be our label right here. So now what it's going to do is it's going to say, okay, take color +1, which is the 8, store in COL, comma X, right there. It increments 1, x to a 1, so load COL plus 1, which is this right here, comma x. X is now 1. So it takes the 7 and stores it in COL, comma x, 0, 1, pushes it there. We're essentially taking everything in this array and copying it 1 over to the left. But because the 9 gets overwritten by what's in the 8, we need to know what the very first color is so we can bring it back up to the bottom in the color bar. Does that make sense? Probably not. Each one of these is a color being painted on the screen. And we're going to move all these values to the left one so that the raster bar appears to move in a circle, rolling. We want to keep the 9 and we want to put it back at the very bottom. And when the 8 is in this position, we want the 8 to come back at the bottom. And then what we're going to do is we're going to pull a value back from the stack using PLA, and we're going to store in COL, comma x. And that should work. I'm going to go over this again because I know I do a shit job of explaining. That works, but it doesn't work because I'm overwriting There we are. There's your first color bar. Now it's not perfect, but it is working. And if we go into the assembler and we look at what is happening, so we've put 7F in DC and DDOD. You don't really have to, you can read up on it if you want, but for now, it's just going to confuse you, I think. And then where we put number sign less than and number sign greater, you see it put in the true values, CO2A. And at CO2A is where our routine is, right here, right after the RTS. 52 is where we said we want you to fire the routine. So when it reaches, when the painter guy gets to 52, we say, okay, we've acknowledged the interrupt. We load X with 0, we load CO64, which is our color bar. You can see now it's 717899. So 717899, it's moved themselves over, right? And we always keep the 0 at the end. And that's why when I first ran it, the whole screen changed color, because you don't want to put the 9 here. This is the last color. We want it to be 0 so that the rest of the screen remains black. So we get the color. We load DO12, compare, put it into Y, compare Y. If it's equal, go back up. So keep waiting because we want to make sure that the painter guy is on a brand new line before we start painting with a new color. And then we store that color in the border and screen. Then we increment X, we compare it to 8, 0, 1, 2, 3, 4, 5, 6, 7. By the time it hits 8, we want it to exit. And then we reset DO12, reset it every cycle so that it knows you want to do it again at 52, that position there. And then this routine here, I'm going to change it up a bit, just so in case you don't understand how push works. So we're loading X with 0, load A with color plus X. So it takes the 9, stores it in 828, just a temporary value, temporary location. Load the memory location of color plus 1, so here, store it in COL, not COL plus 1, but COL, so that is right here in memory. So the 8 goes there. The 9 is gone, the 8 goes there, like that. and then it increments x. So it takes COL plus 1, because x is now 1, and puts it in COL comma x, where x is 1. So that would be right here. See, there's two different positions. There's COL, which is right there, and COL plus 1, which is there. And as you increment x, the two move in tandem. I can't really understand it for you. I can just try to explain it. And then it goes 0, 1, 2, 3, 4, 5, 6. You want to stop there because you want to keep that 0. You don't want the whole screen to flash. But what we can do, and then we're taking, for the very last position, 0, 1, 2, 3, 4, 5, 6, 7, we're loading A with 828, and we're storing it at COL, X. We're putting back what we took off. So we're shaving off the first one, but we have to put it back at the end. And I've increased the size of the array by 1. Oh, that didn't work out the way I wanted it to. What's wrong here? I think I never know what the hell to put. It's always just a guess. It's not showing the black strip though. 7. Okay, so yeah, we gotta do 8. No, I see what's going on. Okay, so, well, that doesn't look any better, but you can see that that is indeed a raster bar. But what if we set a value, we're taking the 52 and we store it in FF, and then we load FF, store it in DO12 and increment it. That should, in theory, change the value of the Y position every time we want. There we go. Do you see that? Of course you do. That's kind of cool, isn't it? So what I did was I put 52 hex into DO12 because that's where we wanted the raster to fire originally. And I also copied it into FF. And then down here I'd load what's in FF and put it in DO12. So the next time it makes its way down the screen, it fires the raster routine. But I also increment FF right there. If I decrement FF, what happens is the value it's pulling from FF is going to go down 1 instead of up. And it's going to change the raster line that it fires on. I just hope that you're understanding all of this. And it's moving upwards. Okay, it doesn't look quite right because it's scrolling in the same direction that it's moving. But increment FF. There, that looks a little better. We can change the colors up. In fact, what we can do is we can go 6, 14, 3, 1. You get to know these after a while. Shades of blue, shades of gray. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think it's 21. Compare number 21 And it should, if all goes well, go through red, blue, and gray. Kind of, sort of. Kind of, sort of. Doesn't really look right, though, moving down the screen. So we'll put it back to the original value, which was 52. And I'm going to go through it one more time. Okay, that really does not look nice. Oh, I see why. Okay. Yeah. I see why. Okay, so ideally what you want is you only want to print 8 of them, and then you make a separate routine to rotate the colors. So there should be 2 routines. I'm trying to print too many colors to the screen, and it's messing up the raster. So that's kind of it in a nutshell. If we go into the monitor and look at 0314, 0315, it is now pointing to CO2C. If we don't put in the store DO19, it really messes things up. You need to let it know that you've acknowledged the interrupt is occurring. So you can skip this part if you're still unclear, but star equals 49152. So that's the start address. SEI, just to halt everything while you make some changes to the system. Load 7F in hex, store in DCOD, DDOD to disable the CIA interrupts. Then you load DC and load DDOD just to clear whatever was pending. We take the low byte of IRQ and the high byte and repoint 0314, 0315 from the original EA31 to IRQ. Redirect it, just like you're redirecting the chore list for your house cleaner. Set DO11 to 1B. This is not something that is really important right now. It's more so for the people in North America. Just know that the DO12, it uses 2 positions, and we'll get rid of that. We don't need that. Store 1 in DO1A to enable Raster IRQs. CLI, meaning that you want to resume the interrupt process. And you don't have to have RTS. You can put a routine here to print to the screen, or let's do that. Let's go. Let's call it wait JSR FFE4, which is get a key from the keyboard. Branch equal wait. So as the user pressed a key, no, branch equal, go back up. And then call JSR FFD2, which prints whatever is in A, and that will be returned from the FFE4 routine. Jump wait. I know I'm kind of going crazy with the code, and I feel like I might be losing a few people. So I'm now typing poorly. Milasoft was here. I go shift clear screen. Hi there, white. Reverse. Change colors. And that's working because we've set up the interrupt, so we don't care about it anymore. It's going to do its own thing in the background. Instead of going to basic with RTS, we're just saying we're making a label called wait. Go to FFE4, which is get key from the default device, which would be the keyboard. If nothing is returned, if you press nothing, it sends a 0 back. which means it's branch equal. Think of it like branch equal to 0. Go back up and keep waiting for a key. Now that you've pressed a key, it puts it in A in the accumulator, which coincidentally FFD2 prints whatever's in A. So it's a two-step process. Get a key, print it, jump back up to wait. If you want, we can do one other thing. We can put a compare number 13 branch equal exit RTS, grab a key. Is it branch equal? Go back up and wait. It's going to fall through if a key has been hit. Compare it to 13, which is the return key, if you learn how to spell it properly. Is it equal to 13? Yep, exit RTS. Otherwise, just print it. So now what it will do, SYS4M152, we print. Oh, I pressed return prematurely. Clear screen, white, hi there, shift return. This is a demo, shift return. Press return. Yeah, now I don't know if you can execute it over top of itself. Apparently you can, but it's best just to reset it. So that's going to conclude this lesson on interrupts. This is a little bit of an advanced level code. If you want to do just a simpler interrupt, then we can do this, of course. We can assemble, this is the bare minimum. Let's say 50, 0314, 03 and 0315, so it's going to point to 0350. CLI, clear the interrupt halt. RTS, go back to basic. And at 0350, increment DO20, decrement DO21, jump EA31, send it back where it should go. And there you are. That's the simplest interrupt you can get. If you manage to get a music routine out of a game or a SID, then of course you can change that at 0350. But I think we'll do that for our next video, how to play music in the background. That would make a very good video. I apologize in advance if this is a difficult to understand video. I've kind of gone from 0 to 100 in the span of a single video. But we're going to slow it down, and I'll backtrack for the next video when we do playing music. And this will be attached as a file in the video. All right, thank you for watching. We'll see you in the next one.